The purpose of this lesson is to explore other relationships in circles. We're going to try looking at angles inside and outside of a circle. We just looked at some of the factoring. Hopefully you're able to factor like a pro now. As you look at this, intersecting lines in a circle, two lines intersect a circle. There are only three different places where the lines can intersect. The idea is they can intersect on a circle, inside a circle, and outside a circle. We already spent some time talking about this on a circle. And the idea here is that if we remember, the angle is equal to 1/2 the arc measure. So the angle is worth half the arc. And that's kind of what's going on in this picture, is that if we have this angle 1 is going to be half of arc AB, and angle 2 is going to be 1/2 of arc BCA. Together those should equal 180 degrees, 1 and 2, because they're a linear pair. And the entire circle should be 360, so half of 360 is that 180. Kind of an interesting idea here with theorem 1. Another idea here is inside the circle. Notice this is not at the center of the circle, but it is inside the circle. And the idea, this is the way I think about it, is now the angle here inside the circle is going to be equal to 1/2 the big arc plus the small arc. So when we look at this, we have, say we're looking for this angle right here. We have sort of a big arc right here and a small arc right here. We'll just add those two up and divide by 2. You'll note these, that if I look at angle 1, I'll have DC plus AB, and then I'll divide that by 2 to find angle 2. I'll look at actually AD out here and BC right here. So it's kind of, by extension, the intercepted arcs. The third place we can have this is outside the circle, and these are pretty tricky. I usually try to focus on these a little bit more because students have a hard time seeing these. You'll notice that with these, they intersect two places. There's a small arc and there's a big arc. So very similar, the angle here is going to equal, angle equals 1/2 the big arc minus the small arc this time. So this is going to actually be a subtraction where this is an addition. So if we look at this, in this case we're saying BC minus AC, and we divide by 2. In this case, we say PR minus this other PR here, and then we divide by 2. In this case, we say XY minus WZ, and we divide by 2. So those are how we find the measurements. And these can come up in a lot of different ways, and we'll take a look at those right now. Sometimes I don't like the way that things are written here, but we'll take a look at these. We see that this is 124 degrees, this arc TU. We could also notice that ST is also going to be 124 degrees. Part of the reason behind that is because TV is actually a diameter. It's hard to tell, but it is a diameter, making this entire part here 180 degrees, and this part 180 degrees. These are parts of a semicircle of the circle. So that means that 180 degrees minus 124 will give me this angle here, or this arc here, and 180 degrees minus this arc here should also give me 124, so that's why that's 124. The idea here is that the way you should write this is you should write the measure of arc, maybe I should call this TSV, and that's going to actually be 180 degrees because it's a semicircle. If you just say TV, I don't know whether you're talking about going this way or that way. It doesn't really matter. Both of them are 180 degrees, but I am talking about a semicircle, so I should use 3 letters in my notation. When I talk about the measure of SV, SV is then going to be this little piece here. So if I talk about 124, remember this is a semicircle, so I'll subtract 124 from that. I'm working without a calculator, so I'm hoping that's 56 degrees right down here. That means that this piece over here, VU, this arc should also be 56 degrees. Next, I'm going to look at the measure of angle STU. Excuse me. So S to T to U. I asked the question, where is this intersection? This intersection is actually on the circle. So I know that on the circle, the angle is half the arc. So my total arc was 2 times 56, so half of that would just be 56. So I'll just write 56 degrees. To see a little bit of work there, you might write, we add these two together and we divide by 2. It's actually this whole arc together, and I divide that by 2, or say 1/2 of it, to equal that piece. The last one's a little bit harder to visualize, so I'm going to switch colors for it. I'm talking about angle VWU. So what I'm going to do is I'm going to trace this whole line right here and this whole line right here. The intersection, where is it? It's outside the circle. So I have to talk about this big arc that goes out here and then the small arc that goes right here. So I'm going to take the big minus the small. So again, this is big minus the small. For me, that's going to be 180 degrees minus 56 degrees. Again, we're also doing the 1/2 on this. I have a calculator right here, maybe. Can I find one? 180 minus 56 equals 124. When I divide that by 2, I get 62 degrees as my measurement. We'll continue the same process down here. Actually, why don't you try these 6 problems for just a minute, and I'll come back through and work through them really quickly for you. So pause this video right now. Why don't you try these 6 on your own, and I'll come back and talk to you about them. Welcome back. Hopefully you had some success with these. We'll notice where is this angle? It's on the outside, so I'll use the 1/2, the big minus the small. The problem is here, I know the big, that's 170. I still have to find the small. So if I take the whole circle is 360, I'll take 360 minus 170, and then I'll also subtract 135. That would give me that this arc right here is going to be 55 degrees. So I'll say 1/2 of 170 minus 55. 170 minus 55 gives me 115. When I divide that by 2, I should get 67. Oh, let me try that one more time. 170 divided by, 170 minus 55 equals 115. When I divide that by 2, I get 57.5 is what I'm looking at. I don't know why that doesn't seem right. So 170 plus 135, I subtract that from 360, that gives me 55. I take 170 minus 55, that's 115, divided by 2 gives me 57.5 degrees. So that's how big angle 1 is. That doesn't seem right to me, but we'll be okay. The process is what really matters. Angle 1 here, to find the measure of it, again, this is on the outside, so I'm basically going to take this big arc out here, minus the small arc out here. I don't know how big either one of those is. So what I need to do is actually need to take a step back and look at some other information. It tells me this is 64, and this is actually on the circle. So if this is 64, this has to be 128 degrees, because remember the angle is half the arc. If that's 128 degrees, the whole circle is 360, so I take 360 minus 128, and this big arc out here is 232 degrees. So again, I'll say 1/2 the big minus the small, and this is sort of my terminology. That's 232 minus 128. 232 minus 128 gives me 104. Again, I'm doing the 1/2 of 104. 1/2 of 104 should be 52 degrees for how big the measure of angle 1 is. This next one, the measure of angle 1, again, it's on the outside. So I'll say 1/2 the big minus the small. Again, my big is given to me, that's 85 degrees. The small I have to track down, so if I take 95, 85, and 175, that's 355, so it only leaves 5 degrees left for this really small arc right here. So that'd be 1/2 of 80, which is 40 degrees for the measure of angle 1. I'm going to try this middle one. It's pretty straightforward. The idea here is this is 234. So the other part, I just take 360 minus 234, and that gives me 126 for this arc out here. So this big arc right out here. Notice that I'm on the circle. When you're on the circle, the angle is half the arc, so it'd give me 63 degrees. Angle is half the arc. These two problems are exactly the same. It looks weird because there's all sorts of like crisscrossing going on. So the idea here is that I see number 1 is on the outside, so I'm going to do 1/2 the big arc minus the small arc. The problem is I don't know the big arc, or I don't know the small arc. So what I have to do is I have to actually use the 65, which is on the inside. Notice it's on the inside. So with inside angles, I say, well, 65 is going to be equal to 1/2 of 93 plus whatever this arc is out here. I'll just call it x. So again, 65, this angle here is on the inside. So I say 65, the angle is equal to the 1/2 the big plus the small right there. I multiply both sides by 2. That would give me 130 equals 93 plus x. Subtract 93 from both sides, and I would get x equal to 37. That's how big this arc is right here. I'm going to get a little bit more room. So then I say to find the measure of angle 1, I'd say that's going to equal 1/2 the big minus the small. Well, now I know the big angle is, or arc is 93 degrees. My small arc is 37. Take 93 minus 37. I get 56. Half of 56 is 28 degrees. Very similar process over here. This is on the outside, so I want the big minus the small, and then I divide by 2. I don't know the small, so I'd use this 93. So I'd say 93 degrees is equal to 1/2 the big 142 plus, again, we'll say this is x right here. It's a 192. Multiply both sides by 2 to clear the fraction. And that would give me 192 plus x. That's a 42. I don't know why I keep saying 92. That's a 4. Subtract 142 from both sides. I'd have 44 equals x. And that gives me my small angle. So then I can say the measure of angle 1 equals 1/2 the big minus the small. The big being 142. The small being the 44 I just found. Again, we're going to do 1/2 of that. 1/2 of that would be 98 degrees. And 1/2 of 98 degrees is 49 degrees. That's the measure of angle 1. Lastly, we're going to look at the same concept of setting up equations. And the idea is you just still need to know the property. So when we look at these, the intersecting lines here are going to be on the outside. So we're going to use the idea that the angle is equal to 1/2 the big, so maybe I'll write this using brackets, minus the small, 2x minus 20. Now the problem is a lot of students will mess this up because if I go one more step into this, I would have 3x plus 17 minus 2x plus 20. A lot of students will miss this plus in here and it'll create quite the disaster. So make sure that you have your plus here, that you're distributing that negative across both parts of the parentheses because this entire thing represents our angle. So we need to make sure to distribute that. I'll again multiply both sides by 2, so that would give me 2x equals, see 3x minus 2x would just be 1x. 17 plus 20 would give me 37. Subtract x from both sides and x equals 37. Pretty easy process. I could also see them extend this a little bit further and ask you maybe what this arc was. So just simply substituting the 37 in and solving that way. This is a really similar process. This is on the outside, so we'd just say the big minus the small. Shouldn't be a huge deal. This guy's a little bit more complicated. Let's look at this guy because I really like the factoring component that works into it. We'll notice this is on the inside, so we'll say the angle is equal to 1/2 the big plus the small. It doesn't really matter which one's which, so we'll just say like this. I'll multiply both sides by 2 to get rid of the fraction, so that'd be 18x plus 8 equals x squared plus 22. I'm sorry, plus 11x. Sorry about that. I don't know what happened. That's supposed to be a 1. I'll then, since there's an x squared and an x in the equation, I'll basically move everything to one side. So I'll say 0 equals x squared. When I subtract 18x, trust me on this would be negative 7x, then minus 8 on this side. To solve for x, what I need to do is I need to factor. So that's x minus 8 and x plus 1. Using the zero product property, that'd be x minus 8 equals 0, or x plus 1 equals 0. That would give me that x equals 8, or x equals negative 1. Now this is an algebra class. Both those answers are going to work, but since this is geometry, we need to make sure that it works for our scenario. Negative 1 seems like it would be problematic up here because you'd have negative 11 degrees, and that's just not going to work in our circle. So I could definitely cross that out. I check the 8. 8 times 11, that would give me 88 degrees here. 8 squared would give me 64. 8 would be 72 plus 4, which is 76 degrees right there. So I say 64 plus 88. 64 plus 88 is 152. Half of 152 is 76. So I'm doing just fine. 8 is my only solution. Your homework is listed down below. It may have changed, so make sure to check out Blackboard. This is probably what your homework is going to be. If you see some changes on Blackboard, make sure to follow Blackboard versus whatever I'm talking about. If you have any questions, make sure to come and ask me or message me.